All right, let's get more technical. Let's not just talk about the vocabulary about what these words mean. Let's actually do some stuff and say this is equal to this. We've already done one. We already said the central angle is equal to the arc that it cuts off. All right, so we said that that was true. Let's do another one. Watch what if I, and remember this is the central angle is from the center. You follow me? So the angle that I'm going to draw right here is not from the center. Oops, I didn't leave myself enough room. Let's start down here. Okay. All right, so let's go to here, to here. All right, here's an angle, but do I call that a central angle? Why is that not a central angle? It's not at the center. That's right. The vertex is on the circle itself, isn't it? Do you see it? The vertex is right on the circle. It's not at the center. So the angle that it makes is not equal to the arc that it cuts off, because that's only true when it's at the center of the circle. You see it? This thing right here is called an inscribed angle. Let's just jot that down. This angle right here is an inscribed angle. Now, an inscribed angle means the vertex lies right on the circle itself. It's not outside the circle. It's not inside the circle. It's right on the circle. So the point has to be on that circle. Everybody got it? All right, now it cuts off an arc. Now look at this arc right here. This arc right here, let's try to sketch it out. Oh man, almost had it. Oh well, that kind of cleans it up for you after I do it. Okay, so this arc right here, we'll call it arc AB for lack of a better term. Okay, so arc AB, if this angle right here, let's say was, I don't know, let's say it's 40 degrees. All right, this angle is 40 degrees. This arc is not going to be 40 degrees. It's actually twice as big as what this angle is. So when I take this arc and I take it all the way down to here, it's going to be twice as big as what this, or this arc is going to be twice as big as this angle. So what is arc AB then? 80 degrees. Make sense? Of course, it goes the other way too, doesn't it? What if, let's get rid of this. What if I didn't know this angle right here and I was told that this arc was 80 degrees? What would this angle be? It'd be 40 degrees. That makes obvious sense, doesn't it? Okay. You with me on that? So that's one thing that you have to remember, that the arc is twice as big as the inscribed angle. All right? That's inscribed. That's when it touches the circle right here. The arc is twice as big as the angle. With me? All right. Let's do a little bit more with this. Let's do this. Let's start from another spot. I'll tell you what. Let's make this a different color. We'll go blue again. It's kind of easy to see the difference. Let's start from here. Watch what I'm going to do, though. I'm going to cut off that same exact angle. I'm going to take this to A. And let's think about what this is going to be. And I take this to B. And I want to find this blue angle right there. Should be pretty easy to see. What do you think? What if I asked you to find the value of this angle right here, the measure of the angle? What would it be? Why? Yeah.
Well, don't both arcs have to add up to the major arc or the big arc?
No, we never said anything like that. Now look where this angle cuts off. This angle goes to here, goes to A, doesn't it? And this other part of the angle goes to B. So what arc does this angle cut off? Yeah, give me a number. Give me a number. You're right, it's AB, but give me a degree. 80 degrees, right? It cuts off an 80-degree arc. So this is an inscribed angle, isn't it? It cuts off an 80-degree arc, so it has to be what? 40 degrees. See it? What if I did this? Let's go to another color. Let's go this crazy purple. Oh, goodness. I didn't leave myself enough room again. All right, what if I went to here and to here? Without hardly thinking about it now, what's this angle right here going to be? It's going to be 40 degrees, isn't it? What do all three of these angles do? They cut off the same exact arc. So anytime you have two inscribed angles, two or more inscribed angles that cut off the same arc, what must be true about every one of those angles? Well, Yeah, it's half the arc, but what's the relationship between the angles themselves? Look at it. 40, 40, 40. What are they? They're all what? They're all the same. They're all equal to each other, right? They're all equal. Do you see it? So when I have an inscribed angle cutting off the same arc, two or more inscribed angles cutting off the same exact arc, what's true about all three of those angles, or all four, or all five, depending on how many you have? They're all going to be what? They're all going to be equal to each other. Does it make sense? So what if I didn't even know the value of, let's get rid of all this. I'll tell you what, let's get rid of all of this mess, except for the circle. Okay, watch this. What if I don't put any, goodness, sorry. Alright. Come on, why is it doing that? Oh, because I wasn't clicking the right button, that's why. Okay, watch this. What if I did this, right? And then I did this. And I call this, I don't know, let's call it something different for the sake of just being different. C, D, E, F. Alright, that's all I gave you right there, okay? And I said, tell me something about angle E and F. What could you tell me about angle E and F without any numbers whatsoever? That they're exactly the same. That angle E equals angle F. Everybody see that? You know what they might do? I don't know if this is going to work out just because I haven't worked out this problem. This is just off the top of my head. Let's say this angle right here was, let's get rid of these arcs. Let's say this angle right here was, I don't know, 2x plus 3, and let's say this was 5x minus, I don't know, 2. Is that all right? And I said solve for x, or I even said solve for the angle, or I could say solve for arc CD, to tell you the truth. Okay? I could ask for all those things. And that's all I give you right there. What would you do with these two angles? That's right, you set them equal. Now, I don't know if this comes out even. I probably could have picked better numbers, but no, yeah, I'll tell you what, let's go 1. I think it'll work if we put a 1. I just want it to come out even, that's all. It doesn't have to, but I just want it to. I think that might work. Let's see. 5x minus 1, right? Equals what? 2x plus 3. So let's do this. No, I was good before. Oh, goodness. Let's say this was 4x minus, I'm sorry. Just being dumb. I just wanted to come out nice, that's all. Doing it for your benefit, okay? Alright, so let's say instead of being a 5, let's say it was a 4. Alright, let's try that. So what do? Subtract 2x from both sides, right? Add a 1, it's 4, so what's x? It's 2. Alright, so x is equal to 2. Let's find out what this angle is right there. So put a 2 in for this. 2 times 2 is 4 plus 3 is 7. Yeah, this is dumb because there's no way that's 7 degrees. Again, I told you, I was just doing this off the top of my head. Alright, but if this was 7 degrees, tell me what arc CD would be. It would be 14 degrees. Now, I know that's not accurate at all, and I'd have to pick some better. You can see how hard it is to actually come up with a problem, isn't it? You don't just throw numbers around. I mean, to make it look right, you got to really think about it. But anyway, it's good enough for us. Then that's how you would find that arc right there. You make sense? And how do you know these angles are equal to each other? Because they cut off what? The same arc. If they cut off the same arc, the angles have to be equal to each other. All right, we killed that thing, haven't we? Let's go to another topic. All right, here's another thing. We're hitting basically a whole entire chapter just in half a lesson here. All right, so we're going pretty quick. This is stuff, though, that supposedly you're supposed to have in geometry a couple years ago. All right, but let's do this. I'm going to draw a diameter. All right, so there's a nice pretty diameter. And watch what I'm going to do, though. I am going to, let's do some other color so it stands out. Watch this. I'm going to pick anywhere on the circle. That's not any particular magic point or anything, all right? It's just anywhere on this circle. What I'm going to do is I'm going to cut off from here to there. Do you see what I did? So look what I've done. I want you to tell me what that angle is right there. Without any numbers whatsoever, I want you to tell me the degree of angle B. And back it up, not just say, well, it looks like it. Why is it 90 degrees? You're absolutely right. It is 90 degrees.
It intersects that straight line of A and C.
You got it. Okay, it's an inscribed angle. That's right. Very good. So it hits right here and it hits right here, which cuts off this arc right here. How many degrees is this arc? 180 degrees, right? Because it's a semicircle. Everybody got that? So if this arc right here is 180 degrees, you see that? From there to there. Right, this has to be half of that arc, so it has to be 90 degrees. Agree? Watch. Remember I said it didn't matter where on the circle that I did this? Because look, I could have gone like up here if I wanted to. If I cut off a 180 degree arc, what's that angle always going to be? It's always going to be 90 degrees, isn't it? You see that? So anytime I cut off any inscribed angle that cuts off a semicircle, that angle is going to be 90 degrees. It's kind of cool, isn't it? All right, let's move on. All right, here's another deal. What if I inscribed, sorry about that, if I inscribed a quadrilateral? Now, inscribed means the vertices have to lie right on the circle itself, okay? So let's go here. A quadrilateral is how many sides? 4. Now, I'm just arbitrarily drawing sides, okay? I'm not trying to make them equal. I'm not trying to make them anything special. All I'm doing is just hitting right here. You with me? Now, I'm not going to go through any explanation of why this is true, but I want to show you this, that we'll call this ABCD. That's supposed to hit right here. It doesn't look like it does, but pretend it does, okay? All right, so ABCD. So this is an inscribed quadrilateral. You may want to jot that down, inscribed quadrilateral. What's true about this is that these opposite angles right here, the ones that are opposite each other, you see how they're directly across from each other? Not the ones that are next to it, not the consecutive angles, but the ones that are opposite each other, they will always be supplementary. If you think about it, I'll go through an explanation. It's really not that hard to see, because look at angle C. What's it do? It cuts off this arc right here, doesn't it? What's angle A cut off? It cuts off the rest of the circle, doesn't it? So really, they're both cutting off, what? 360 degrees. Well, if the arcs, or if the angles right here, the inscribed angles are half of the arcs, guess what it's going to add up to be? Guess what these two angles are going to add up to be? No. 180, because the angle is half of the arc. Do you see it? So watch. This one and this one cuts off this arc. This angle right here cuts off the rest of the circle, so together they cut off 360 degrees. Well, what's half of 360? It's 180. So guess what must be true about the angles that are opposite each other on an inscribed quadrilateral? They're equal to 180 degrees. So angle A plus angle C would equal what? 180. What do you think would be true about B and D? Angle B plus angle D would equal what? 180. So give me a geometry word though. Instead of saying they add up to be 180, no, they're not similar. It's a S word though, but it's not similar. No? Supplementary. They're supplementary, okay? So the opposite angles, listen, it gets a little wordy, but listen to what I'm saying. The opposite angles of an inscribed quadrilateral are supplementary. Told you a little wordy, but does it make sense? The opposite angles, A and C, of an inscribed quadrilateral, right? 4 sides, they all hit on the circle, okay, are supplementary, which means what? They add up to 180. Get it? Okay, let's move on. All right, let's try to go through this pretty quick. Watch what I'm going to do. We're not going to talk about the arcs now. I'm just going to talk about these things. Now, I'm drawing two what? What did we say at the very beginning those were? Chords, okay? Let's call this little a and little b. So A is the line segment from here to here. B is from here to here. You with me? And that's C and that's D. This is kind of quick, little easy thing. I'm not going to go through a proof on why this is true, but I'm just going to show you. If I take A times B, not adding them up, I'm multiplying them together. If I take A times B, that's going to equal, what do you think? C times D, exactly right. All right. So I'm not going to put some examples in here, but you could put some numbers in here, have one of these as your variable, right? You plug the stuff in, and then you just do your algebra. So you take the two segments, A times B equals C times D. Now, this is only true if they intersect inside the circle. You with me? So if these intersect inside the circle, this is true.